Patrick, in trying to understand the process by which the brain makes what we call mind, it's sometimes interesting to look at very specific things, like pain. You've worked on that.
I've worked on pain. Pain's a very, very interesting experience because it's so strong. So when you're in pain, it's the whole of your subjective world. But what studying pain particularly shows us is that our mental life, our subjective experience, is really the product of two rather different streams of activity in the brain, which are normally called bottom up and top down. So to feel pain, you generally need a stimulus. And the stimulus that we're using is radiant heat on the skin, which we can deliver using a laser. And that's really important because we can deliver heat pain without touching people. And that's quite important because you can deliver an experience of pure pain without any of the tactile contact that you would get if you touch people with, I don't know, a needle or a hammer or something like that. So we can deliver a small burning sensation to the skin, and that will be conducted up nerves, the spinal cord, and into the brain. That's the bottom-up part. And the top-down part is that the brain controls its own input. It's very, very good at this. So we all know about the examples of soldiers who are able to fight on the battlefield despite wounds that would seem to be really impossibly painful. That's, it is thought, because the higher areas of the brain are able to suppress the incoming signals from the tissues of the body. So we're quite interested in to what extent is our subjective experience of an event like pain due to the stimulus, the actual heat energy delivered to the skin, and to what extent is it actually related to some much more general features of how our mind is working. And I'll just give you one simple example that we've been working on, which is a surprising effect called visual analgesia. So we've discovered that if we deliver these painful radiant heat sensations to the skin of the hand, that it feels less painful if you're looking at your hand while this happens, compared to if you're looking at something else. So the way that we do this is we have a control condition where, for example, we'll put your hand in a box so that you're looking at the box, but you're looking in the same direction as your hand, you're attending towards the same part of space, but you don't actually see your hand. And what we've robustly found is two findings. First of all, pain ratings are lower. If we ask people to rate how intense the pain is on a scale between 0 and 100, say, they'll give lower ratings when they're looking at their body than when they're looking at something else.
And you know for sure the pain is the same because you can control the power of the laser and the heat.
We control very carefully what the actual stimulus is at a physical level, but the subjective experience depends on what you're seeing. But as well as getting a subjective rating of the intensity of pain, we can also measure different aspects of how the brain processes the signal coming up through this bottom-up pathway, either by doing the experiment in a brain scanner or by measuring the small electrical activities generated as a result of brain activity through electrodes on the scalp. And what we found is that there's a reduced activity of the so-called laser evoked potential, which refers to the electrical activity generated in the brain by the incoming signals triggered by the laser. So not only do you feel less pain, but your brain is able to reduce the extent to which it responds to the bottom-up pathway simply by looking at your hand. Now, why is it that looking at your hand matters? I think it's something to do with the multisensory experience of our own body. I think we experience ourselves not just as being hands and feet and skin and different sensations, but as a whole. And I think there's something about the experience of oneself as a whole, as if you like a unity of self-consciousness, to use a big term, which is able to provide this regulation of what we feel. So when you can have a representation of yourself simply by getting this visual input from your own body, you're able to exert a top-down control over the bottom-up pathway. And I'll just give you a rather nice, interesting example of that. When I started talking about this visual analgesia work,
Analgesia meaning
reduction of pain, people used to say to me, well, what should we do when we go for a blood test and the doctor gets out the needle? So the standard advice is always, don't look at the needle going in.
Right.
Now, of course, I think there are two things going on here. When you see the doctor coming at you with a needle, that's a little bit scary. But looking at your arm, that will actually be analgesic, as our research shows. So my advice would be, if you possibly can, don't look at the needle, but look at your arm.
So what is the significance of that in an evolutionary sense, or for the well-being of the organism?
Well, anything that reduces pain is not only potentially significant from an evolutionary point of view, but also might have quite important applied significance for people who are in pain. So pain research is often important and applicable for the human condition generally. But I think the general ability of the brain to regulate and adjust how it responds to inputs is one of the most beautiful examples of just how flexible human cognition is. If we were constantly responding to all the inputs that arrived on our skin and on our retina in the same way, we'd just be slaves to our environment. Right. We'd be prisoners of where we were and what was happening to us.
And this happens in all the senses.
It happens in all the senses. I think the example that we've discovered in the case of pain may be particularly interesting, perhaps because it's particularly useful. But the general principle of the top-down construction of what we actually experience is a very general idea that we don't just perceive what's out there, we perceive what it's relevant for us to perceive given what we're doing now. So the human brain has this amazing flexibility, not just to passively replay what the environment throws at us, but to give us experiences which are really a product of what we're currently trying to do, where we currently are, what we're currently thinking about. That's the flexibility of human psychology. We don't just perceive what's out there, we perceive what is relevant for us to be perceiving given the situation we're in now.